Chapter 5.6, Imaginary Numbers, Complex Numbers. Well, we're going to discuss imaginary numbers, expressions with I, the highest power of I, and complex numbers, A plus B, I. Obviously, the I stands for I and imaginary. The square root of a negative number is not a real number. Now, we know if we have an even integer, we cannot find two numbers that multiply to give us a negative. So normally when we see this with an even integer, our answer right away is not a real number. But in this chapter and section, we're going to be talking about imaginary numbers. Now, what actually is an imaginary number? I will always stand for the square root of negative I, and I squared will always represent negative 1. Now, these are the definitions that you have to memorize. The main one is I equals square root of negative 1, and I squared equals negative 1. So when we come down here to simplify, what we're always going to do is pull out the square root of negative 1, because that multiplied by the square root of 7, because remember we always multiply what's inside and also what's outside. So this is negative 1 times 7 will give me the negative 7. But I pulled this. Now this actually represents I. So instead of writing the square root of negative 1, I can write I times the square root of 7. The square root of negative 1 is the I, and that is your answer. Looks a lot nicer than that. Let's go to the second one. They're all the same. Here I have the negative with the even index. Normally we'd say not a real number, but we're talking about imaginary numbers now. So therefore you pull the square root of negative 1, and then you have the positive of whatever the radicand is, because negative 1 times 36 is negative 36. So instead of writing the square root of negative 1, we're going to write I, and that's multiplying the square root of 36. But we know what the square root of 36 is. That's 6. So we're going to have I times 6. Remember, the I is multiplying. There's no addition, subtraction here. And normally we don't write something like x times 2. We'd write 2x. And here you're going to do the exact same thing. 6i, and that's your answer. Okay, the next example. Here, again, there's a negative, so we pull out the square root of negative 1. And that's times 20. Well, this is now I, so we write I. Square root of 20 is 4 times 5. We're going to pull out the 4 here to make it a 2. And remember, the 2 is all multiplying. So this is going to now be 2i times square root of 5. And that's your answer. Going on to the next one. We're going to do multiplication. Now remember, these are the two things you have to know. I equals the square root of negative 1, and I squared equals the negative 1. Because we removed the radical symbol. Okay, the rule for multiply. You cannot multiply radicands when they're negative. So if we can't multiply a negative 2 times a negative 5, what we're going to do is we're going to pull out the square root of negative 1 to represent the square root of negative 2. And here we're going to pull out the square root of negative 1, and we're going to have just the square root of 5 left. Because when we multiply this, this is the square root of negative 5. All right. Now the square root of negative 1 is I. So you're going to write I square root of 2 is really multiplying I square root of 5. And when we multiply the radicals, remember we multiply what's outside, and then we multiply what's inside. So I times I is I squared. And the square root of 2 times the square root of 5 is the square root of 10. Now we have I squared. Oh, here we go. I squared equals negative 1. So instead of writing I squared, I'm going to write negative 1 times the square root of 10, which is negative square root of 10. The next example is we have the square root of negative 7 times the square root of negative 7. Now again, we cannot multiply these the way they are. You cannot multiply radicands that are negative. So you have to take out the negative symbol. And the way to do that is take it out as a square root of 1. It still is under the square root. And you have 7. Here you have the same thing. Square root of negative 1 times square root of 7. Square root of negative 1 is I. So we're going to write I square root of 7 times I square root of 7. I times I is I squared. Square root of 7 times square root of 7 is square root of 49. I squared is negative 1. So we're going to say negative 1. Square root of 49 is 7. Answer is negative 7. All right, let's go on. Notice we're doing the same thing in each of these. We're just pulling out the square root of negative 1. And if we see an I squared, we're going to make it negative 1. So let's see. We're going to do the numerator first. We have to pull out first that square root of negative 1 before we can do anything else. Now we're going to have, instead of the square root of 20, I'm going to have 4 times 5. All under square roots. And now the square root of 80, we have to pull out the square root of negative 1. And 80 is going to be 5 times square root of 16. Now, why did I pick the square root of 5? Well, I looked here first. And I knew that I'd be able to remove the square root of 4, but I was going to have the square root of 5 left. It doesn't always work, but maybe 5 would go into 80 and I could get that square root. And it worked. And that was good. So now we take a look at this, and we're going to have this square root of 4 is 2. We're going to have 2i, square root of 5. The square root of 16 is 4, 4i, square root of 5. Now we're going to simplify. Remember, they're all multiplying. That's the only way you can do it, because they're multiplying. The square root of 5 cancels. The i's cancel. 2 over 4 is equal to 1/2, and that's your answer. Let's go to the next one. All right, we have the square root of negative 3 and the square root of negative 7. All right, so pull out the square root of negative 1 in the numerator with the 3. Pull out the square root of negative 1 with the denominator of square root of 7. And we come over. We have I square root of 3, I square root of 7. And the i's cancel. And our answer looks like the square root of 3 over square root of 7. Aha, there's one problem. One problem is that it's like having 0 in the denominator. You can't do it. You cannot have a radical symbol in your denominator. So we have to now go and multiply both numerator and denominator by square root of 7. Actually, absolutely. This is now the square root of 21. And this is going to now be 7. And that's going to be your answer.